Sincerely, channel companions in this session from the Introductory Robotics Training course, we wanted to introduce software tools and programming languages, Gene Robotics, so that with these tools, familiarize yourself so that you have a good mental background, so that when we start working practically, it will be easy for you to learn. So I suggest that you watch and remember this session carefully until the end. Well, when we want to start building more advanced robots that can perform relatively complex or even very complex commands and tasks, we must also master programming software systems in robotics, because without software and programming in robotics, robotics can never go forward and make 10 turns. The simplest example is that when you want to control a robot with Bluetooth, you must use microcontrollers and communication modules. Well, the use of microcontrollers means that you must know how to program a microcontroller, which is a type of programmable IC such as A-Vari ICs or SP series and the like. In the following, we will discuss the topic separately so that you can learn well. We start the topic with programming in robotics. When it comes to programming robotics, it means that we first build the physical body of the robot and add memory or a programmable unit to it or consider it. Of course, the fact that we build the physical body does not mean that we make the robot more complete and clone its body. They want to make a C program later, but the meaning is that at first we consider the required hardware, which is actually the microcontroller and ICS. What we decide to do with the robot, or in other words, what the robot's work should be, has an effect on what kind of leash we should choose. For example, if you want to build a robot that only clears a specific area and path and guides itself, then you need a simple hardwired and very small and not very complex touch program. Because it is only supposed to detect obstacles and follow a specific path, such as an environment or a circular path. But when we want to build a robot that does complex things like picking up and putting down automatic path recognition devices and performing operations to perform better movement, whether controlled by a human or autonomously by the robot, then we must choose Helix hardware, and we will definitely do Helix programming. So depending on these tasks, our type of programming is also determined, and we must decide what language to use for programming at all. It is better to know that you can program the robot with almost all programming languages, such as C, IE, or Python, or Java. For example, one of the most popular languages for programming CSEs is now various C languages. CE is a language that has become more popular with the advent of hardwired microcontrollers like Arduino. In many cases, several programming languages share used to complete a robot. In the following, I will give an example of a robot in which several languages must be used to better understand this issue. For example, if you want to build a robot that moves and performs operations based on camera images and image processing, one of the choices is to use two languages, C, IE, and Python. In such a robot, we do the hardwired programming with C and program it, and we connect the control and image processing unit with Python, and these two parts communicate with each other and communicate. And as a result, the robot is well guided and controlled. For example, when we want to actually do the image filling and receive outputs from the image that these outputs are converted into commands, we have to program this part with Python, which is actually one of the best languages for this task. And when Python creates these commands and now wants to transfer them to the motor so that the motor comes, for example, an arm and move, that motor is actually going to be controlled by microcontrollers, right? The programming language of that microcontroller and the hard drive and the motor will be the SETI++ language. And these two languages will communicate well with each other and exchange data with each other. And in this way, the robot works well. So you can use all kinds of programming languages in robotics. But in this quick robotics tutorial, we will use two languages, C, IE, and Python, as well as MicroPython. When the time comes, you will learn to be familiar with these languages and how to work with them, but I strongly suggest that if you don't know these languages, you should definitely start learning them today, as there are many educational resources for them, fortunately. Or if you know them better at a beginner level, continue and reach at least an intermediate or semi-literate level, which is very, very necessary. So take this seriously, because if you don't learn these languages today, when we enter the advanced world of robots, which will be very interesting and great, you won't be able to do anything, and it will be very confusing for you. and you might even get cold and not be able to continue. Therefore, the MC Robotics program comes first. Of course, when we get into practical aspects, you will realize more about the importance of programming languages, and you will learn how to program robots well. But note that we will not teach the language itself. For example, we are not here to teach Python and its grammar, but rather we will use Python or the language we have chosen to program and build robots so that you can learn robot programming and how to use programming languages for robots, which will be very easy for you if you know that language. The next software item in robotics, which we will discuss in advanced robots, is the Robotic Operating System, or RAST, which stands for Robotic Operating System. Because robots also have operating systems that you should know well, we will teach you the types of robot operating systems in the next and more advanced robotics series. You will learn how to work and use them, become proficient, and see how much using the robot arm system can speed up your work and allow you to create unimaginable and professional robots. That means even you won't believe that you can easily implement such robots. The next thing is simulation, robotics, and familiarization with things like digital twins. The concept of digital twinning is very sweet, yet practical and complex, and we need to teach it in its own right, which we will do. But here, to give you an idea, just say that you're actually initially creating a robot in a virtual world in the form of a simulation. And you'd see it. And when it reached an acceptable level and came out of the test with flying colors, you would create both a physical and real model, and now you have both a real and physical model. A digital model where you can even connect the physical and real model to that simulated and digital model. And whatever you do with the digital type, it will repeat exactly the same thing in the physical model. So, concept of this action is shown in this image. You see, it should be noted that this digital and simulation environment for robotics is highly dependent on the right environment or the robotic operating system and can be said to be in that category. So, if we want to summarize the section related to robotic software, it can be programming languages, robotic systems, and simulation and virtual robot terrain. Fortunately, there is also very good software for designing and simulating this virtual robot, which I will introduce to you in the following and teach you how to use it. I have also put the downloaded link along with this video in the description section for you so that you can easily download it. So here we go. Double-click on the software, which is like this. And then when we double-click, the software will load, and after it is loaded, we click on Next here. And we check this again and click on Next. We click Next again and install until the software is installed. Here we wait until the software is installed. So after the software is installed, we must tell you what to do. Activate the software because it is not active. After it is installed, you will see that its icon appears on the desktop. You will see this icon. Then when I double-click it, a page like this will open. Here, we must enter the name and other information. We must enter the serial number. To activate, we copy the name in the name section. We also copy and paste it in the email section. In the next section, we copy the serial number and the activation code and paste it in the relevant section. And we click OK. Here, this message is shown to us, which actually says that software has been successfully activated. So we don't have to do anything with these files anymore, and we open software. We double-click to open software. When the software opens, you will encounter such an environment and a screen that you can see here that on this side, in this box, the tools and all the parts that we can use are placed to make the robot's body, and in fact, the robot itself. You can see that we can easily select each one. I will make it a little bigger. And then it has various menus and tools, which of course I will teach this software. Here I just introduced it and told you how to relate it. We see that when we bring an object, for example, the robot's body in 3 dimensions, we can completely use it. And it is a very, very excellent software for working in the robotics field, which I will teach as I have described so that you can learn and deepen from a general software that will be very useful for us, whether for getting hired or for the guidance that you give from work and a personal company or a school. It will be enough. For example, if you learn the programming part of the VTS and microcontrollers for robotics well, you can clone a maneuver on that topic and create a resume and become a member of this board because it has enough branches to keep you busy and busy. Or you can focus only on building the hardware instead of the C robotics program. Although whichever path you take, it is mandatory that you have some knowledge in other branches. In the presence of this, you can't say, well, I'm only going to the programming part, and I don't want to know anything about hardware at all, because it should be so that if you want to do robotics programming, you should be able to know the hardware and microcontrollers and be able to work with the hardware to some extent. Otherwise, you won't have a clear perspective and want to do proper programming. And this method applies to all paths. If you want to learn all the paths yourself, that's not a problem, and you can learn and progress in parallel. In this robotics training series, we teach the middle ground so that you can be promoted in all cases and learn well. Well, this was a general introduction to the softcore path in robotics. Next, I want to talk a little about the types of robots. So far, I have actually provided you with important issues, and these were a general introduction to the softcore path of robotics, so that you can get acquainted with the types of robots, what types of robots there are, and how many categories they are divided into. First of all, robots are divided into two general categories, which include mobile robots and stationary robots. And the next categories are placed in these two categories and are divided. First, we introduce the robots in the mobile category, which include flying robots, wheeled land, crawling robots and floating robots, which of course are other mobile land robots, but this is the main category that I have presented to you. Any robot that flies, swims, or moves on wheels on the ground is classified as an animated robot. The next category is stationary robots, which does not mean that they do not move. They just do not move and work in the same place and do their job. Like the traditional arm robots that you see here, or any robot that only stands in one place and works, they will be in the category of stationary robots. When we always want to use robots in our lives, whether for home use or for use in tradition and business, the robot must be used for the purpose we have, and the robot must be built and designed according to our purpose. For example, this arm robot that you see is not just used in tradition in large companies like self-construction. You can even make several robots for your drawing table in the electronics workshop and develop it so that it can be your helper or the same assistant who can pick up something, or do things that require high precision and should not have hand tremors. Robots do it, and it is natural that for such a purpose you can build a stationary arm robot and put it on your table. You should know that, by the way, we will also describe such a robot for our electronics workshop and put it on the electronics workshop table so that we can get help from it. To do sensitive tasks that are difficult to do with your hands, and even for your learning, we will build this same robot for ourselves together with you so that it can be used to, which will make you join us and learn well and more, which is your goal of learning. Well, I think the explanation is enough for this session, and if you are just watching this video and did not watch the previous session, I suggest you start watching the first session. And of course, the playlist for this course is also located at the bottom of the video description section, so stay tuned for the next session when we're going to explain the reason for designing the body for the robot.